All right, welcome pre-AP pre-calc students. I am going to talk about skill 16 today, which is using basic trig identities. So today we're going to talk about some Pythagorean identities that we are going to use. And so we'll start by recalling some information that we know. We know that the tangent of an angle is going to be equal to the sine of that angle divided by the cosine of that angle. And we know cotangent is the reciprocal of that, so it'll be cosine of the angle divided by the sine of that angle. Okay. We can express secant as the reciprocal of cosine, so 1 over cosine. And we can express cosecant as the reciprocal of sine. Notice that in all four of these situations, everything is in terms of sine and cosine. Okay, that's going to be important. All right, so the first identity that we are going to talk about is the main Pythagorean identity, cosine squared plus sine squared. Well, what would that equal? Well, let's start by thinking of our unit circle, center at the origin, radius of 1. And when we did this, we know that this is our angle theta. We know the x-coordinate is the cosine of theta, and the y-coordinate is the sine of theta. And so what we end up with is a right triangle. So if I were to use the Pythagorean theorem on this, I'd have cosine squared theta plus sine squared theta equals 1 squared. Okay, this is just me using the Pythagorean theorem. And since we know that 1 squared is just 1, we know that sine squared and cosine squared, when you add them together, makes 1. Okay? Alrighty. So that's going to be our numero uno super importanto. Sorry, that's not very sensitive. But that's going to be our very important first rule here. Okay, so cosine squared plus sine squared equals 1. Now, I do want to draw a couple of corollaries from here. So knowing that this is true, we could say that cosine then, if we subtract sine squared from both sides, is equal to this. And we could say that sine squared theta is going to be 1 minus cosine squared theta. So if I were to solve for sine squared, I would subtract cosine squared from both sides. All right, so I just wanted to kind of point those out. So these are a couple of auxiliary ones that we could have. All right, so now how can we show that 1 plus tangent squared is equal to secant squared? We're going to verify that this is true by rewriting both sides in terms of sine and cosine. Okay? So I'm going to have 1 plus, for tangent squared, I'm going to write sine squared over cosine squared. For secant squared, I'm going to have 1 over cosine squared. Okay? The next thing I'm going to do is get a common denominator. So when I look at my fractions, I know that my first fraction, I need to multiply top by cosine squared theta and bottom by cosine squared theta. So that gives me the equation cosine squared theta over cosine squared theta plus sine squared theta over cosine squared theta equals 1 over cosine squared theta. Now looking at this part right here, apparently I can't highlight on this for some reason. Looking at this part right here, we can see that we have cosine squared plus sine squared. We have a common denominator, so we can add the numerators together. This yields, so cosine squared plus sine squared is 1. And both sides check out. So this is another identity that we need to know. 1 plus tangent squared equals secant squared. Okay? Now for the last one, we have 1 plus cotangent squared equals cosecant squared. So we're going to do a similar process. Cotangent, remember, is the reciprocal of tangent, so tangent is sine over cosine. Cotangent would be cosine squared over sine squared. And cosecant squared would be 1 over sine squared. Okay, so we're going to get a common denominator. And so when we do that, we're going to multiply this 1. We're going to multiply top and bottom by sine squared. And that's going to give us sine squared theta over sine squared theta plus cosine squared theta over sine squared theta equals 1 over sine squared theta. Well, once again, we can see we have this sine squared plus the cosine squared, and we know that's equal to 1. So this becomes 1 over sine squared theta equals 1 over sine squared theta, which means both sides check out, and that means that this is another identity. Okay, so now how are we going to use these identities to solve problems? Well, let's start with a problem like this. You'll see similar problems on your assignment later. For this one, we have some ordered pair, negative radical 45 over 7, comma y. So we know the x-coordinate. And it lies on the unit circle as shown right here. It's in the third quadrant. What is the value of y in the simplest form? Okay. So when I'm looking at this, we have to remember that ordered pairs in the unit circle are written as cosine theta, comma sine theta. Well, that means that this is our cosine theta. So what we have to imagine here is that we have this angle theta, and we're trying to figure out the y value of it. Now, this is clearly not in the unit circle, but what we can do is we can use our Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. We know the cosine squared. So we're going to set it up as such. So I know the cosine value is my negative radical 45 over 7. So what we're going to do is we're going to solve this for the sine squared. This part, when you take a negative and square it, you get a positive. So we're going to have 45 over 49. We're going to subtract 45 over 49 from both sides. And we get sine squared theta equals. Now on this, we're going to need a common denominator. So 1 whole is the same as 49 over 49. So 49 minus 45, that leaves us with 4 left over. And now to get rid of the square, we're going to take the square root of both sides. Sine theta would then be 2 over 7. But let's take a look at this. Look what quadrant we're in. In the third quadrant, x-coordinates and y-coordinates are both negatives. Okay? So we have to put a negative on our answer. Technically, this would be plus or minus 2 over 7, but just know that we need the negative this time because of what quadrant we're in, okay? So that's how we're going to do a problem like that. Okay, let's go and try another example. Given that sine of theta is positive 3/4 and our angle theta is in quadrant 1, so they're telling us where this will be. Here's theta. Sine of theta, opposite is 3, hypotenuse is 4. We want to find the exact value of the cosine in simplest form. So we could just do this by using Pythagorean theorem, or we could do a Pythagorean identity. We know sine is 3/4, so sine squared would be 3/4 squared, which would be 9/16. If we subtract 9/16 from both sides, we get cosine squared theta equals, we got to get our common denominator, so 1 whole is the same as 16 over 16. 16 minus 9 is 7. And when we take the square root, we get cosine theta is radical 7 over 4. And in this case, we are going to need the positive root because we are in the first quadrant. Cosine is positive there. Now keep in mind, you could have gotten this by just doing the Pythagorean theorem. You could have done 3 squared plus b squared equals 4 squared. Whoops. You'd have b is radical 7. And you could say cosine of theta is radical 7 over 4. So you could have gotten it that way too. But I wanted to show you that you could also use a Pythagorean identity. All right, last one here. It says here, using this identity, so they're telling us what to use, find the value of sine theta to the nearest hundredth. So we're having to deal with a calculator now. If cosine theta equals negative 0.25, and we know that our angle is between pi over 2 and pi. So what that means, pi over 2 is up here, pi is over here, so we are in the second quadrant. Now notice that they're giving us the angle in radians, so we're going to make sure we're in radian mode on our calculator. So you probably want to go ahead and check that real quick. And we're told that cosine theta is negative 0.25. So we have sine squared theta plus cosine squared theta, which cosine theta is 0.25. I'm using my calculator to figure out 0.25 times 0.25, which will be 0.0625. We need to subtract that from both sides. Sine squared theta, 1 minus 0.0625 is 0.9375. We'll take the square root of both sides. And sine theta is about 0.97 when rounded to the nearest hundredth. Now, they don't ask us to find the angle, so the fact that I told you this needs to be in radian mode, I probably didn't need to say that. Although if you were asked to find the angle, then you would have to use radians. But they just asked what's the value of sine theta. So this would be the value of sine theta. All right, come to class prepared to ask questions. We'll go over examples, and then you'll have a chance to do some more practice.